A stack data structure follows the last in, last out principle, which is known as LIFO or LIFO. So, but LIFO stands for last in, last out. So you can think of a stack as an empty container, just like this one here. I got this image from programmers. I'm giving them that credit. So this empty container, you can add something, you can also remove something. Okay. When you add something just like this is called push. Here you can see another item has been added to the container. Right, we now have two items in a container. When we add another one, so these methods are called push. When you remove an item from the container, this is called pop. Stack has 5 operations. However, it only has 2 main operations, which is push and pop, just as you've seen here. Only 2 operations takes place here, the push and the pop, which is add and remove item. Okay, so the push add element to the top of the stack, just as you've seen here. The pop remove the top element from the stack. You can see that here. You can see it removed the top element from the stack. The peg return the value of the top element without removing it. So it means give me this top element without removing it from the stack. Is empty checks if the stack is empty. Is full also check if the call stack is full. Alright, let us go to the visualization of stack. So we have two implementation of stack. You can use an array and you can also use a linked list. So guys, let us understand this visualization. So you can think of a stack here and we are keeping track of the top element. So the stack is currently empty. I am going to add the value 5 to my stack. I'm going to click on the method push. Yes, you can see what happens. We now have 5 in the stack. Let me add another one. I'm going to add 9. So you can see 9 has been pushed to the stack. So 9 is the second element, and you can see the second item is the item at the top of the stack. So I'm going to insert 8. Same thing happens. And I'm going to click on pop. Click on pop and you can see it locates that element at the given position and return it back to me. Let us implement this in code. I'm now my VS Code and I'm going to create a file. I'm going to call the file stackarray.py. Alright, so the first I'm going to do is to declare a class. I'm going to declare a class and call it stack. Okay, then I'm going to define the constructor. Alright, so I don't need a name and I only need the self. Okay, the stack should have an item, a container. So I'm going to call this as the container, and the container is going to be an empty array. Okay, so the next thing I want to do is to define the methods of the stack. Okay, I'm going to define the first method, which is empty. Okay, this is going to take in the self. Then I'm going to return the length of the item in the stack. So I'm going to do it like this. Okay, let me just do it like this. If the length of self.items is equals to 0, so this is going to return either true or false. It is important we start testing immediately. So let me go down so that we'll test this first method. Okay, so I'm going to create a variable which is going to be an instance of the stack class. And I'm going to print the result. So this is going to be stack dot I think it should be is empty. Yes. So let me run this and see what we get. I'm going to run. Okay, is empty. It says true. The stack is empty. Okay, let us go ahead and implement the push method. So I'm going to create another method. I'm going to call this push. So push, you take in the self and the item we want to add to the list. Okay, so this is going to be self dot items dot push. Sorry, this is append dot append. So we're going to append the item. Okay, this is the method push. Okay, so before we print out the stack, there is empty. So let us add an item. So stack dot, I think, yes, push, yes. So we want to push the value 34 to the list. So let us run again. Let me play my console. So I'm going to run this time. The expected result should be false. You can see false. It means we have an item in the stack. All right. The next one we want to implement is the pop. So I'm going to create a method and call it pop. So pop should take in only one parameter. Okay. So which is no. Pop should not take any parameter. Okay, because pop should remove an item from the stack. Okay, so before removing an item, we should check if the core stack is empty. Only when it is not empty, that is when we want to remove an item from the stack. Okay, so I'm going to check if not self dot is empty. Okay, so if it is not, we want to return self dot dot pop. Okay, we want to return self dot pop. Otherwise, we should return none. Okay, so this is going to return the last element at the top of the stack. Okay, so this should be self dot items. Okay, items. Sorry about that. Okay, so let us test this implementation. So we have one item, then we're going to check if it's empty. Let me move this at the bottom. So we should have pop. Pop should not take any arguments. All right, so I'm going to save. Then, okay, let me duplicate this and bring it down. Okay, so this is like we add an item to the core stack. We check if it's empty or not. Then we remove the item in the core stack and also check if it is empty or not. So I'm going to save. Clear my console. I'm going to run. Okay, good. Now you can see the first printout says there is something in the core stack, and the second one print out true because we removed the only one item in the core stack. So next we want to implement pick method. Okay, and what pick method does, from my slide, you can see the pick method returns the value of the top element without removing it. Okay, so let us implement that. So I'm going to create the method def. So I'm going to create the method pick. Then pick should take the method of the class, nothing else. Thereafter, we also want to check if the call stack is empty. If it is not empty, that is when we want to perform this operation. Otherwise, we should return none. So I'm going to check if not self dot is empty. Okay, that is when we want to return the last element in the call stack. So this is going to be -1. -1 will return the last element in the call stack. Otherwise, we should return none. Okay. All right. So this is it. Now let us test this function. So I am going to remove the pop. Then we've confirmed this. So I'm going to call stack.pick. Okay, I think I should print this out. Let me print this out. Okay, so let me run this. You can see we have 34 at the top of the stack. Okay, let me add multiple items. So I'm going to add 4, then I'm going to add 55. I'm going to save. The expected result should be 55. You can see that is that. If I also swap this line and save, the expected result should be 4. Run. You can see we have 4. So the next implementation we want to do is size. What is the current size of the stack? Okay, so we are going to define the method size. So size will not take any parameter. Then what we want to do is to return the size of all the items in the list. So we're going to do return self.items. This will not return the number of the items, so I should wrap it in a length. So I'm going to do length of this. So this is going to give me the resize of all the elements. So let us test this function out. Then I'm also going to print this stack.size. Okay, then I'm going to run. Let me clear my console first, then run. You can see we have 3 items in the call stack. So there is another method. This is just like a bonus. Okay, this is like a bonus. So we want to see every item in the call stack. Okay, so just like the linked list, like we did in the previous module. So we can just do display. When we call display, okay, so what it's going to do, we're going to loop through every value and print it out. So it's going to do for every value in self.items. So we're going to print it out. So we're going to print the value that exists in the stack. Okay, so let us call this method. I'm going to call this method stack.display. Okay, this should be in a new line. Alright, so I'm going to run and let us see what we have. So we have 34, 55, and 4. The next thing I want to do is to explore the time and space complexity. So let me close this. Alright, so the first method we have here is empty, and you can see here we are not looping through an item that depend on the input, and also there is no extra space. So this is constant time and constant space. Okay, so guys, the next method we have is push, and what this does is to append an item to the list. So I believe this is O of 1 because we are adding an item to the end of the list. So this is O of 1 and this is also O of 1 space. Okay, let me write this here. The next method is pop. So what is going on here is we are calling another method which is O of 1. And all we need to do is to remove the last item from the list. So this is also O of 1 and O of 1 space and time. So this is actually a lookup, the peak. So we are calling another method. Remember, this is O of 1 constant time and space. And accessing an element through the index is O of 1. Okay, O of 1 space and O of 1 time. Okay, so this is O of 1 time and this is O of 1 space. For the display, we are looping to every item, but we are not making use of an extra space. So this is O of 1 space and this is O of n time. So guys, this is the implementation of stack using an array. Let us implement stack using linked list. I'm currently on Visual Algo and I'm going to create an empty stack. Okay, then I'm going to add an item. So I want to add 11 to the stack. Now you can see the item that has been added to the stack is the head and the tail. So let me add another one, 61. The head is the 61, right? Is the node with 61, which has the value I just added to the stack. So I'm going to add another one. And you can see that is how it works. So what if I remove an item? Okay, let me remove an item. Let me remove this pop. So it removed the last item which was added. So the last item is always the head. What about peak? Let us look at peak. You can see it gives me the value of that item without removing the item. So same implementation, same way we have seen. That is what we are going to implement. All right, guys. So let us move to VS Code. So I'm going to create a file and I'm going to call this stack link list. Okay. So the first thing I want to do is to create the class node. This should have a constructor, and this constructor should have self and data. So by default, the data should be equal to the given data, and it should also have the next property, self.next. Okay, sorry about that. Let me call this line. So self.next should be none. Okay, so this is the class node of the linked list. I already had a video for both single and double linked list. I'm going to put them in the description. So that will give you a clear understanding of the single and double linked list. So the next thing I want to do here is to create another class. And this is going to be the linked list. This should also have the constructor. And the constructor should only have the self. Okay, let me remove this. So you should have the head, right? The head. And the head should be none by default. Okay, so the first method we want to implement is to check if it is empty. So I'm going to do is empty. Is empty should take the self method. Is empty. Okay, there is no parameter. So next I want to return the head if it is empty or not. So this is going to be return self dot head is none. Okay, so if it is none, it's going to return true. If it is not, it's going to return false. Okay. Um, the next method I want to implement is append. Okay, so I'm going to implement the append. Append is going to take only one parameter, which is the data we want to append to the linked list. Okay, so I'm going to create the instance of a new node. Okay, so this is a node with the data which is in the parameter. Okay, so the new node, what I'm going to do here is to first of all check if the head is empty. If the head is empty, I'm going to assign the head as the new node, and I'm going to return. Okay, otherwise I'm going to loop through and set the position of the new node. Okay, so what I'm going to do, if is empty, okay, this should be self dot is empty. So if self dot is empty, okay, so what I'm going to do is to set the self dot head. So the self dot head will now be the new node. Okay, then all I want to do, I think, can just you can just leave the return the way it is, or you can just return true. Okay, so otherwise I want to get the current head. So the current is equals to self dot head. Okay, so I'm going to loop and set the position of the new node. So I'm going to do y current dot next. Okay, so I want to set current will be equal to current dot next. Current dot next. Okay, so if the last element is found, what I'm going to do is set the next property of the current to the new node. So it's going to be current dot next, which is equals to the new node. Note here that I am out of the loop. So this is the loop, and as soon as there is no next item, the while loop is going to be terminated. Then this part of the code will be fired. So the next property of the current node, which is none, will now be the new node. Okay, so let us test this. So I am going to create an instance of the linked list class. Let me call this. Okay, so the first I want to check if it is empty. So I'm going to check dot is empty. Then I want to append an item to the linked list. So I'm going to append 3 to the linked list, and also I want to also check if the linked list is empty. So what is going on here is check if it is empty, add an item to the linked list, then check if it is empty again. So I'm going to save and run this code. Good. So we have true. Where is it? Okay. So this part of the code print out true, meaning yes, it is empty. Okay, then we add an item to each. Then this other part of the code prints false, it is not empty, which is correct, shows everything is working properly. So I implemented this as a linked list. I'm going to make some tiny changes here. Okay, so I'm going to scroll to the top. First of all, I'm going to change this to stack. So F2, the name of the class is going to be stack. And if you look at the bottom, and if you look at it here, you will see the name has changed. And I am also going to change this F2. I'm going to call this stack. Okay. And the next thing I want to change here, I want to change this head. Instead of head, I will change it to top. Okay, I'm going to change it to top. I believe it should change everywhere it is. Okay, you can see this is correct. One more thing I'm going to change, okay, is empty checking top. Okay, so I also need to set the top here. Then this is going to be self dot top is equal to new node. Okay, good. So let me run. Hopefully everything should still work the way it is. All right, great. Everything still works. So the next thing I want to do is, okay, before I go, let me change this method. I'm going to change this method to push. Okay, good. That works. And if you look at it here, you can see this is push. So the next method I want to implement is pop. Okay, so what I'm going to do is to define that method. I'm going to call it pop. There is no parameter. So what I'm going to do here is to check if the stack is empty. So if the stack is empty, all I have to do is to return null. Okay, so dot is empty. Okay, so if it is not, then I'm going to do pop item. The pop item will be self dot top dot data. The data is, I want to get the item first before I pop it out. Okay, so the next thing I want to do here is to set self dot pop. So self dot top will be equal to self dot top dot next. Okay, then I want to return the popped item. Okay, so let's test this if it's gonna work. All right, so this is gonna be pop. So let me add some couple of elements. I'm gonna add 2, then I'm gonna add 10. Okay, we've confirmed this. I'm gonna remove this. Save. Clear my console. I'm gonna run this. So it popped out 10. Okay, what if there is no item in the list? I'm gonna save and run again. So it returned none, meaning there is no item in the list. Excellent. Good, that works. So the next method we want to implement is pick. Okay, so I'm going to define a method, and I believe we know what pick is doing. So if I check here, so pick should return the value of the top element without removing it. Okay, so what we're gonna do is there's not going to be a parameter. Okay, so we're also going to check if it is empty. We just want to return none. So if self dot is empty, okay, we want to return none. Okay, otherwise we want to return the value in the top data. So this is going to be return self dot top dot data. Okay, so that is for pop. No, that is for peak. Okay, so let me release this. Then I'm gonna print out the stack dot peak. So I'm going to clear my console and run. Okay, it gave me 10. Try to remove an element. Stack.pop. Sorry, I made a mistake. I have to invoke this as a function. Sorry about that. So let me save and let me clear my console. Okay, so I'm going to run. So peak returns none. Okay, let me comment out this part. Or no, let me comment out this part. So let me add a label so that we know where it's coming from. So I'm going to save and run. So the peak is 10. Okay, so let me add the pop and run. So the peak is none. So something is wrong with the peak method. Let me see. So basically it works fine. Okay, let me save. I expect this to be 2. Okay, so I'm going to pause the video and come back with a solution. So guys, I found where the problem is coming from. So the push method is adding the new node to the end of the linked list. If we look at the visualization, you can see every item, which is every new node we push to the stack, it add it at the head. Okay, so if I push this value, you can see it's going to become the new head. So in the current implementation I have, if I push a value, it's going to add it as a tail. So that was where the problem is coming from. So this is where the problem is. So I'm going to remove this part of the code. I'm going to remove this part of the code. Good. So what I'm going to do is add an if statement. So this is going to be s, the new node dot next, okay, is going to be the self dot top. Okay, so then the self dot top, okay, let me call this, oh sorry, the self dot top is going to be the new node. The relationship has been established. So this is it. So I'm going to save and run again. I added 2 pop method. So I'm going to run. You can see it pop out 10 and it pop out 2. So what if I pop out 3 times? So you can see it pop out the 3 item. It pop out the 10 followed by 2 followed by 1. So now the peak should be none. So run this, the peak is none. So what if I comment out 1? The peak should return a value. So the peak is 3. So 3 is at the top of the stack. What if I did not pop anything? Okay, let me save and run. So we have the peak is 10. The next method we want to implement is the display method. So I'm going to create the method by typing the name of the method, which is display, and this is not going to take any parameter. Okay, so I'm going to loop from the top. So the current is going to be self.top. Okay, so I'm going to do while. I'm going to use while loop. So while current, okay, so while there is current, I want to print the value. So I want to print the current dot data. Okay, so I need to add some space here, so I'm going to do something like this. Okay, so I think let me add like something like this. Okay, or like this. Okay, so the next thing I want to do is to set the current, which will be equal to current dot next. Okay, so that is it. So I'm going to run. Before I run that, okay, let me comment out this pop and call the method stack.display. Okay, so I'm going to run. You can see we have 10, we have 2, and we have 3. All right. So, guys, this is stack implementation using a linked list.